about group theory. Make sure you don't skip because you'll miss the mind-blowing conclusion. So here's a little definition of group theory. It's a set G with like a binary operation, and it has to satisfy some axioms. But probably, you can read that, but you should probably just look at some examples. So, here's some modular arithmetic. If you look at that picture, it's a picture of a clock. And there it is. So you can have a set G that goes from 1 to 12 inclusive. And if you do x plus y, or you start at time x and go for y hours, there's some examples. If you start at 3 and go for 12, you get to 3, because 12 is the identity element, which means it's basically like 0. So 5 plus 12 is 5, and, well, 3 plus 9 is 12, because 9 is the inverse of 3, and so 3 plus 9 is 0. 9 plus 10 plus 11 is 6, and 9 plus 10 plus 11 is also 6, because it's associative, like we said in the definition. And you always get a number on the clock, which is the last axiom. Closure. Okay, so now we're going to talk about some equilateral triangles. So you have an equilateral triangle. We're going to label the points 1, 2, and 0. We're going to use reflections and rotations. To go from the one on the top to the one below it, you have a rotation. And to go back, you have the inverse of a rotation. And you can map each one to the other ones with one or more, with one operation. So sometimes you have to use inverses. Epic conclusion. Wasn't that pretty epic?